got a very pretty syntax, very elegant language. And, you know, as I was learning about Elixir, I started missing some things. One in particular, not many, but one thing in particular was I missed having a while loop. You know, sometimes it'd be nice if we could say something. We've got Elixir fired up here. It'd be nice if I could say something like, "Well, true, do, I hope that's hello." I don't know, but Elixir doesn't like that. Now, wouldn't it be cool if I had some sort of, like, I don't know, some hypothetical thing I could import, you know, that then I could, I don't know, do something Elixir-ish, but with a while loop, like something like this. You know, I've just got I just want to fire up a process that loops infinitely, and you receive messages and just print it out until you stop. You know, that'd be kind of nice if I could do that. You know, and then oh, if it actually, you know, worked, that'd be something else. I don't know how we'd ever get a while loop to work in Elixir, because obviously that's not gonna, you know, and then if you stop, it would behave properly with the right breakpoint and stop doing. It'd be nice, if only. Alas, how unfortunate we are. Well, today I'm going to show you a little bit about how you can actually do that with macros. So once again, if you didn't get the chance, please go ahead and clone this repo. It's not required, but there are a few files in there that I'll be using throughout the presentation that you can look into to follow along. Okay, so to start off with, what is a macro? A macro, you can think of a macro as being kind of like a function. Well, what's a function, you might ask, in abstract? A function is just a way to encapsulate some sort of transformation on data. And likewise, a macro is a way to encapsulate a transformation on code. And what this lets us do is metaprogramming. Metaprogramming lets us write programs that write programs for us. Now, don't worry about building yourself out of a job. It's not quite like that, but it can save you a lot of, it gives you wonderful things that will make your work more enjoyable. So to start off with, so macros come in two big kinds of flavors. And one you may have heard of are C-style macros. If you've ever worked in C, you've probably seen something like this. There are, this is what a macro definition looks like. Say square x. Wherever I see square x, I want to replace that with x times x. Whatever x is. X could be anything.
This is a string replacement, right? Just like straight up.
Close, yeah.
Okay.
We'll talk a little bit about that. It's a slightly more nuanced than straight up string replacement, but you can think of it like that. Here's where I invoke the macro. And now what happens at compile time is this gets transformed into that, as if you had written this in the first place. So it happens at compile time, and so that means during runtime there's no overhead costs of expanding these macros. And that's true for macros in Elixir, as we'll see. Macros are also used for defining global constants. Let's see, okay, there it is. Okay, but this is, in brief, how they work. When you compile a C program, the compiler takes your source code, which is it's just a string. That's all it is. That's all the compiler sees at first, and it passes it through what's called a lexer that breaks up the strings in sort of the atoms of the language. So it breaks this up into printf, a left parenthesis, a literal string. That's just how I chose to represent it. I don't know how it's really represented, but a literal string, the token square. This is no longer a string, but a token. It's kind of like an atom in Elixir. It's this atomic thing. You can't. It doesn't have any meaning broken up. That's the square. That gets fed to a parser, which then spits out, it's called an abstract syntax tree. We'll talk more about that later. And then that gets sent to the compiler, which generates the binary code. Any questions so far? Following?
So where does the substitution take place?
Substitution takes place right here. Go back. So the substitution takes place when, after your code has gone through the Elixir, the C compiler says, oh, okay, you've got some macros here, and it looks for this token square. It says, oh, okay, I'm going to take this token, and I'm going to replace it with that. Following me? Okay, so it's a lot like string substitution. You can, like a glorified s//. Said. So now the other kind of macro are Lisp-style macros. This is John McCarthy, creator of Lisp and AI pioneer. One day I hope to have hair, beard, and eyebrows as fantastic as that. Not quite there yet. So Lisp-style macros, in short, they're way cooler. They actually work, and yeah, they operate on the level of abstract syntax trees. We'll get there, and they're the predecessor of Elixir's macros. So let's talk for a moment about these abstract syntax trees. And if any point at this you get lost, please raise your hand. I really like questions, so I need some help with figuring out where you guys are so I can explain things better. Thanks. Okay, so this right here is an expression, simple math expression. As such, you might see in most programming languages. Lots of languages use infix notation. If you've used maybe a stack-based language or a stack-based calculator, you might be familiar with postfix notation. So there are many ways to express this computation. This is just infix notation. There's postfix, prefix, whatever. But if we want to talk about the computation to happen by itself without worrying about the syntax, we need to break this up into its abstract syntax tree. This is what it looks like. Watch closely. Click on it. There we go. Okay. I worked really hard on that language. So this says, okay, I want you to, at every node in the tree is a operation to be performed, and its children constitute its arguments. So here, and note how the parentheses got removed. So this says unambiguously that we should first add 3 and 4, those kind of bubble up, and then that 7 gets multiplied by 2. Now I'm going to show you briefly a little sample of Lisp code that does the exact same thing. This is Lisp right here. Bear with me, I know it looks like oatmeal with fingernail clippings in it, but with all those parentheses, but let me just shift it around a little bit without actually changing its structure. Okay, now if you can rotate that 90 degrees, I couldn't figure out how to do that animation, but if you can rotate that 90 degrees, you'll get a tree. Lisp is actually written in its syntax tree. And what that means is because the source code is so close to its tree, you can operate on the source code as a high-level nested data structure rather than just a dumb string of tokens. That's why we care about the syntax tree. Now, I'm going to go back to that C macro and show you there's actually a little bug that I put in there. Can anyone see? Okay, well, print out what the bug is. But can anyone see why this would print out 6 instead of...
It's the order of operations.
Yes.
It'll divide by 2 first and then multiply.
Exactly, yeah. This gets transformed into that. That's problematic. And that's because C-style macros have no notion of their surrounding context. And so this breaks. Whereas if you contrast this with a Lisp, this is the exact same macro in Lisp. Up here is the macro definition. This is where I invoke the macro right here. And And this gets expanded into 42 times. Okay, so square 42 would get expanded into 42 times 42.
Could you fix the C bug just by putting parens around the macro?
You could, yes, yeah.
But you would have to know you needed to do that.
But even beyond that, when with the C style macro, it's just text, it's just substitution. You're like pattern matching. Well, that's nice and powerful. There's a lot more that we'll see we can do with an Elixir style macro because we actually get the full syntax that we can inspect at compile time. Go in here. So it turns out that Elixir is Lisp under the hood. At least that's what I thought when I figured this out. I was like, okay, this is nice. Like, wait a minute, I've seen you before. This is Lisp. What are you doing? Well, it's not like Lisp. It's got a layer of abstraction between the syntax tree and the syntax we write, which makes writing the syntax really nice. You got the nice infix and the block structure. It's really pretty, but there's actually a way for us to get access to the symbol tree, the abstract syntax tree. So let's follow along if you'd like. I'm going to go back here to my lovely REPL, and let's see. The magic incantation is, let's see, here, I'm going to put my screen so you can see, is this: quote, do, colon, and then 2 times 3 plus 4. Go ahead and run this. See this pop up. You can do this with anything, really. Quote, do, colon, and then any expression. Feel free to experiment. So we get this. I'm going to clean this up a little bit by deleting out this middle list. Okay, so we've seen this before. This is Lisp. You have tuple here, you've got multiply, and then 2, and then the other thing you're multiplying 2 by is the result of summing 3 and 4. Do you all see that?
Mm-hmm.
Okay. So every function call in Elixir gets broken down underneath the hood into a 3 tuple like this. The first being the function, the second being some metadata, and the third slot is a list of arguments. We're not going to worry about the metadata today. There's a lot you can do with that, but I didn't have time to fit that in my presentation. So we'll just focus on the functions and the argument lists, which is a party in and of itself. Okay. Any questions so far? Okay. All right, let's take a look at the pipeline operator in Elixir. This is actually a macro. So does everybody know what pipeline operators?
You mean the pipe?
Yes.
The thing?
Pipe, yeah.
Okay.
It's this thing.
Mm-hmm.
So, just a little silly example I made up. It takes a range of numbers, 1 through 25, filters out all of the odd numbers, and then adds up the result together. Now, here's where I'd like you to follow along. Go ahead and run something like this. It's important to please save it in a variable. We're going to work with the result of that in a few minutes here. So you get this. That's a lot. Let's break this down a little bit. So first, up here at the top, you've got your first pipe with its left and right hand sides. This is actually the bottommost pipe in that expression. And the thing that was on the left and the thing that was on the right. And then there's the second pipe, which is the first pipe that we looked at. It's kind of backwards. The thing on the left, which is the range from 1 through 25. And then the thing on the right, which was the call to filter. So, set, fall.
I just love looking at it like that. A range is the operator is ...
Yes.
Yeah. It has a left and a right. I love that.
Yes, there's a name for it, and it's called dot dot. It's not just fancy syntax. There's a name for it. Okay. With me. There's a lot of stuff.
So it's a smiley operator. The pipeline looks like a smiley.
Is that the Santa operator?
It's like a handsome bearded man.
Yes, that's right.
Yeah, right. We can call it the McCarthy operator.
That's right.
All right. So now here's where the fun stuff comes. Go ahead and run this if you'd like. Macro expand once. There's also a macro expand. We're just going to work on the macro expand. What this does is it takes a syntax tree and looks at all the macros inside of it and does one step of expanding them. You can actually have recursive macros or macros that expand into more macros, which expand into more macros. And so macro expand will loop until there are no more macros to expand. But this just does one step of that. You have to pass it this env flag. I guess it does some contextual sensitive expansion. Just accept the incantation for now. Okay, this is, again, I cleaned up the output of that. This is what we get, and this looks a little bit more comprehensible. We have here, again, a call to reduce with its first and second arguments, and then a call to filter with its first and second arguments. I know what some of you might be thinking. That's a lot to look at, so get that syntax out of my face. Fortunately, we have a solution. Go ahead and, okay, this is the fun thing to run. This will take that abstract syntax tree and print it out for you beautifully as if you had written the code yourself and expanded them by hand. So if you run that, you will be left with this beautiful string.
Mm-hmm.
Now so we could have written that, right? Well, let's look at what we had originally. You can see how this got fed into the opening argument list of filter, which that whole thing got fed into the beginning of enum reduce. Y'all see how that got threaded through?
Mm-hmm.
Now the cool thing is this happens at compile time. And that's actually very important that this happens at compile time. There's a reason why we can't do this with functions. And that's because there's a slightly modified schematic of what we did with Elixir. When you call a function, everything happens inside of this evaluator. So when a function gets called, it receives its arguments after they have been evaluated and executed, or whatever you want to name that. However, with this, we want to actually modify the argument list to a function before it gets executed. So it steps in right before the code actually gets run and says, wait, I'm gonna push apart this argument list a little bit and stick something inside of it. That makes sense?
So you're trying to make the argument that what you do with macros there's no equivalent way to do it with functions. Is that what you're trying to say?
Yes. Yeah. So if we look at this, if pipe were just a regular inline operator, it would not see anything like enum reduce plus. What it would rather see is the result of calling enum reduce plus.
Oh, so the execution of the code happens only after everything's expanded.
Exactly. Yes.
Okay, so nothing is executed. The expansion happens at the compile time.
Yes. Exactly.
Makes sense. Now I'm with you.
Okay. Great.
No.
Did that?
Yeah, well, I mean, I'm like questioning and verbalizing my understanding, I guess, but just like you obviously need to move those arguments into the first position, which is what that type operator macro does for you.
Yes.
before you call filter, because it's gonna, otherwise it would throw an error, because filter takes, 2 arguments.
Exactly.
It takes your list and then the function.
Exactly. Yes.
So,
Precisely. Good. Did that?
So the compile time phase is doing a lot of work for you, potentially.
Yes.
Right?
Yeah. We can do a lot with the compile time phase, which lead to some very exciting speed bumps and or speed boosts, not bumps. Boosts. Boosts. Well, if you write it wrong, it will be a bump. But
Yeah, so maybe another way to say it, in case it helps, is you're trying to delay the execution or the computing of the arguments until after the macro has been able to rearrange things.
yes. Yes. Exactly.
It's like all these lazy functions in the enum module.
Yeah.
They get expanded.
Kind of like that. It's like, I'm not going to compute until I'm done expanding.
Yeah.
I'll wait for a bit.
So I mean, this is just more a general question for everybody, or if you want to answer it. Is the advantage here seems to be just you can write the code more cleanly, like in a vertical way. Is that the only advantage usually for macros? You just like write stuff more cleanly, or does it ever like actually like speed things up?
Well, in one sense, everything is writing something more cleanly. I'll write assembler, right? But there are a lot of there's a lot more than just syntactic sugar that we can get. Good.
Yeah, so pretty much everything in Elixir is a macro. If you dig into it, if is a macro, just everything is. And so the macros are really good at creating DSLs. So if you're working with the migrations, that is a macro. If you're defining ecto schemas, that is a macro. If you're working with the Phoenix router, that is a macro. And so that's one of the places where macros really excel, is being able to basically write DSLs. And yeah,
So
basically simplify the code and make it nicer.
It's less of a compute savings than a programmer savings, right? We have less
Yeah.
code to write.
Yes, the
Yes.
macros make a significant impact on the, or can make a pretty significant impact on the compilation time. So you're trading, compilation time for developer productivity.
Right.
But one of the
Which is
other
most
things,
expensive.
yeah, one of the other things that macros can do is they can actually, write new functions for you. So, like with Rails, right, where you can say like belongs to, that actually, when it expands, that's at runtime because it's not a compiled language with Rails. But it expands into, oh, well, I'll create these other functions for you that have these all, defined relationships and arguments. Like macros can do the same thing.
So if you get lazy and you don't want to write 3 lines of code, you can spend a week making a macro for it, and then
Yep. Once wrote a macro. It took this was in Lisp. It took a DSL I made to describe syntax, like English sentence syntax. And with about 50 lines, I described imperative, declarative, and interrogative sentences in this nice, almost like a regex way. And that built out several hundred lines of code that actually got executed, and it worked. Well, it was exciting. It took me a long time to debug because I didn't do a great job of writing it. We'll get to some tools so it's not abominable. Okay, this is good. Okay. All right. Okay, yeah, so back to here. So the Elixir macro happens right here, plays around with the syntax tree before it gets passed to the evaluator. Just for comparison, this is where the C macro goes. And this is just a flat string of tokens, whereas this is a full data structure that describes the structure of the language. So we get a lot more power that way, and you can feel smug and superior to your C compadres because you get the full power of the parser without having to write a parser yourself. So now to go a little bit deeper, I would like you all to summon your macro powers, and we are going to write our own macro with, we're going to do a reverse pipe. So the built-in pipe sticks arguments at the front of an argument list. If you ever wanted a pipe that could stick arguments at the back, well, we're going to do that. So hold on here, and come along with me to lovely land of reverse pipes. Okay. So, well, I've already written for you. So, let's take a look at end pipe EXS. It's really small. It's a really small thing to do, which speaks to the power and flexibility of macros. You declare a macro with, surprisingly enough, def macro. And now, okay, this is something I learned with Elixir and it blew my mind. You can have infixed macros. Unless everything is a prefix operator. So it was really cool that I could have infixed macros. So what this macro is saying, anytime you see this tilde arrow surrounded by some starting value and then a function call, right? This is the function call. It's that tuple. I want you to replace that with another function call, except I want you to append the start val to the argument list.
Nice. That's like pattern matching against the code.
Exactly. Yeah. You get pattern matching against anything you want. Yeah. So, I mean, of course, because you can do this, you could go even deeper and say, well, okay, if the function is named, if it's the dot operator, or if it's filter operator, you could do some more inspection of the abstract syntax tree. That's something you don't get with C macros. Right now you can take a look at the syntax tree. So let's go ahead and try this out. So if I do Gesundheit, let's see. Go ahead and compile that, and then import. Okay, so let's run this back up. Do I get? Oh, darn, I have my history. Let's see. Oops. All right. There we go. All right. So, so I went ahead and wrote an example of this macro. Let's see. Here it is. Okay. So this takes your. I'm taking a function, and I'm sticking it at the end of the call to enum.map. That makes sense? So go ahead and run it. Ta-da! It works. Now if you contrast that with, it's obviously different from a pipe, just to illustrate this will barf at me. Oh! You can't do a map over a function. I need something enumerated there. So, if we want, we can look at the what happens when we expand this. Let's see. Okay, so not that hairy thing. Oh, toString. And once, expert. Ta-da! And let's see if I what's that? So, this is effectively the same as writing this, and you can see how the function got stuck at the end of the arguments to enum.map. And you might ask, okay, well, how robust is this? Well, it turns out it's not bad. I can do something crazy like this, like use that same thing and then use the regular pipe to pipe this to the minimum, and then I can stick the result of that at the end of another function and run that, and it just gives me random strings of 3 letters. So,
Nice.
I mean, this works. It plugs in. We're not going to break it because we forgot some parentheses anywhere. And you saw how small the code was. It's not hard to do these things. Any questions? Okay. All right. Well, let's see. So, in brief overview, just a few tools for macros. You can get the abstract syntax tree with quote do. You can expand a macro expand once, and then you can pre-print the abstract syntax tree with macro toString. Now, about that while loop, let's go ahead and take a look at that. Now, a disclaimer, I stole this from Chris McCord's book, Metaprogramming Elixir, which you should definitely check out, and we'll give another plug for it later. But here you go. So shamelessly snarked from that. Now, sometimes writing that tuple, like writing syntax trees as tuples, can be a bit laborious, right? It worked very well for the pipe operator, but writing something, you saw how big the thing's expanded to. If I'm going to write anything useful, I don't want to have to work with that kind of tuple. So fortunately, there is a solution, namely this quote. We can also use this quote. This quote just says, give me the abstract syntax tree of this thing, and don't evaluate it. Don't evaluate it. Is that okay? So you can think of this as kind of like a template or string interpolation. We want, anytime we see while, here's where you can name the macro whatever you want. While, whenever I see while expression, and then a do block, I want you to replace that with this try catch block here. And inside the try, you're going to say for, and then just an infinite stream of okays. This is how we made an infinite loop. If you really want to do that. But it works. I don't know how performant it is, but it works. Okay. So while true, loop this thing. If, and then this unquote thing kind of stuffs that expression into the abstract syntax tree. It's like using the pound and curly braces with double quotes, except safer. It escapes things first.
String interpolation.
Yes.
It's like function interpolation.
Yes. Yeah, that's a good. Yeah. So, if that's true, do the block. Otherwise, loop.break. And what's that? Just throw break. Here's the catch block where it breaks out, so it uses the try throw. Glorious abuse of the try catch block. So what this code is doing then is, I spent some time highlighting these. So okay. What this quote says is, okay, give me the thing as an abstract syntax tree. Don't evaluate yourself. And the unquote says, wait, actually, this is a variable. You should actually evaluate me one time and just like slide me in here. Does that make sense?
Mm-hmm.
This is probably how you'll most often write macros. Very rarely will you have to like in the nitty-gritty of the syntax tree.
Question on that.
Yeah.
Does using the try-catch break your tail call recursion? Are you just going to add stack frames every time through?
This is using a for, so I don't think stack frames would be added. Anybody know? It's a good question.
Is for a macro too? Or if so, then it
Maybe.
probably expands into something.
Yeah.
Or should be a macro, I'm pretty sure.
Yeah, probably.
Pretty much everything in Elixir is a macro. Like, quite literally, everything.
That's a good question. Answer, I don't know. Sorry. I'm actually not that much of an Elixir expert. I just happen to know a little bit more about macros. So, right, but that'd be a good thing to find out. I wouldn't necessarily recommend running this production. I have to look and see what Chris McCord says about actually using this file. Any other questions? Okay. So there are some macro safety features. For those of you who can't see, this sign says the construction site must wear a safety helmet. I found that and I loved it. English is the best. Okay. First of all, macros won't inject variables into the caller scope. So if you introduce a new variable, it's like x bar equals something, that's not going to be visible to the callee. When you're expanding macros, when macros expand, it does some special handling of variables, so that behind the scenes, so you don't have to worry about it, but you're not going to blow somebody out of the water, or you're not going to get blown out of the water just because you
You're
use
saying
something's macro.
a variable that's introduced inside the macro itself.
Yes.
Like defined in the macro.
Yes.
Okay.
Yeah. Does that make sense? I don't have an example here, but it protects your variables. These are called hygienic macros. However, there are ways to do things called anaphoric macros. I'll mention where you can find more about that later. But you've got quote and unquote, which saves you from the tedious process of building a syntax tree yourself, and protects you from messing up on that. You also have macro escape. This is if you want to inject a tuple directly into the syntax tree as a literal tuple and not to be interpreted as a function call. We didn't need that here, but good thing to know about. There's a whole bunch in the macro namespace, so macro module. Go check it out. But, so briefly, what do macros cost? Well, there is a little bit of compile time cost. That expansion does cost us something. However, we can actually leverage that to do less computation at compile time, at runtime, excuse me. So you can shift all of your order n operations into the order 1 operation of doing this once at compile time, then shipping, and then you'll be ever having to worry about that ever again. Which is cool. The biggest thing to concern yourself with is maintainability. When to not use macros includes when something else would be easier to work with in the future. A good instance of when you should not use macros is when you can do something with just a data-driven approach, where you use smart use of functional programming, looking at data, doing dynamic dispatching, pattern matching at runtime. That's generally going to be more maintainable. Also, you've got functional programming, and that is crazy powerful. So if you can write it with functions, use functions. Something that you can't do with a macro is pass a macro as an argument to another function, like you can with function passing to another function, since macros get expanded at compile time. So using functions can make your code a bit more orthogonal and reusable. And also, like the mustached man said, this is part of the problem with Lisp. Anywhere you go to, I don't know of any Lisp shops really, but everybody has their own flavor of Lisp because they've worked it to fit their domain so well that you have to know the domain perfectly to understand the language. You're going to make something that people won't be able to understand. So just be careful with not creating your own Frankenstein monster of a language. But when should you use macros? If you need that compile time computation. I'm not going to go into tricks that you can do to actually do significant computation at compile time, but you could imagine some things like handmade optimizations. You could think of something like loop unrolling, or
you could quite literally at compile time have it read in like a CSV file and generate a map out of that, or do something else as opposed to reading it in a runtime.
Exactly. Actually, so, let's see. Got one of these code generation. Let's throw. Okay. So here are the other things. Where is it? I'll pop over here real quick. Read this book. It's amazing. If you get it from pragprog.com, it's cheaper than on Amazon. It comes without DRM, so you can get a PDF, ebook, Modi, all at once, which is really nice. But in that, he talks about how he actually walks through at compile time downloading an API spec from GitHub and then building out functions to call that API all at compile time, and then you compile that and ship it. And so every time you hit that module, you don't have to run out to GitHub and be like, oh wait, what was that API call? But it's all compiled there, and you don't have to rewrite that. It just happens automatically because you do it.
But I can't compile if I'm not online.
Okay, I mean that's one of the things you have to weigh. That's a good point. I'm not.
Turn your Wi-Fi on for 10 minutes and then turn it off again.
If you're relying heavily on the GitHub API, then that's probably going to be a problem anyways.
You can't anyway, because you can't install new mixed dependencies or gems or NPM packages. We're stuck with internet anyway, right?
It's a fair point. Hopefully, where you work, we'll have internet. That's a good thing. If you like pulling Richard Stallman and carrying your laptop to remote Mount Hills of Tibet, then you might run into some problems with that. But beyond that, you're all right. DSLs were brought up. The Active Query Schema, Phoenix Router. The Phoenix Router also is a good example of code generation. When you say it's resource, you make a new resource route.
Mm-hmm.
It builds out a whole bunch of functions for you, and that's done with a macro. You could think of maybe something that takes a Open API, Swagger, YAML, JSON document, and then takes your API spec and builds routers for you with a macro. So you could do that all at compile time without sacrificing runtime performance. Also, okay, here's a really cool example. The string upcase function in Elixir. I think you mentioned this to me.
I don't know.
What's that? Okay. Well, it goes over, Chris McCord goes over this in his book. When you call string upcase, it can capitalize Unicode strings. And they did something really clever with this. When, as Elixir is being built, what that will do is it goes to a file that has all of the Unicode code points defined. It's like Unicode characters.txt or something. And it takes that, and that has a mapping between every character and its uppercase equivalent. And so what it does is it builds out hundreds and hundreds of functions that pattern match on your string, that pattern match on the first character of your string, that return recursively that string upcased with the result of calling upcase on the rest of the string. So it's just chucking it all on the Beam's pattern matching ability, which I think is hilarious. And but they also do it. They all do that at compile time, and that's very clever because they don't have to maintain some. They don't have to worry about writing code every time that Unicode gets updated. They just download the new Unicode spec in the right file format, and let it run from there.
So that means you could upcase a smiley.
I guess if one's defined. Yeah, maybe. Yeah, that's fine. Frowny face gets upcases. Yeah. If you can manage to sneak that in a pull request, I'm sure you could change that definition in your files so that happens. Again, okay. So here's the Metaprogramming Elixir book. Great read. Another fantastic book if you are really curious about macros is On Lisp by Paul Graham. As the title says, it's very much based on Lisp, but this guy is the king of macros. Yeah, this book, well, yeah. With macros in this book, you write prologue in Lisp. It's amazing. And it takes heavy advantage of compile time optimization. So this is the place to go if you really want to get serious writing a DSL. He will take care of you. I'll post these slides later, so don't panic too much. Photo credits, especially like to thank Nacho Libre and Escalato, and thank you very much.
Thanks. That was awesome.
Yeah.